Microcomputer Relay Protection Device is the core equipment of Microcomputer Relay Protection Cabinet. At present, Power System Microcomputer Relay Protection Device is. It refers to the microprocessor as the core component. Digital signal processing, computer software and artificial intelligence are used. An industrial control device to realize relay protection function. Its basic working mechanism is convert the analog quantity from the protected object into digital quantity, and sent to the microprocessor for calculation, processing, analysis and judgment, to decide whether to act. The complete microcomputer relay protection device includes two parts, hardware system and software system. Key relay protection function of the device is determined by the software. Hardware is the basic platform of software. The hardware structure of typical microcomputer relay protection device is composed of data acquisition, switching value input and output system, microcomputer system, human-computer interface and communication interface circuit, and power supply are composed of 5 parts. The function of the data acquisition system is to collect the data from the current transformer. The analog quantity of voltage transformer is converted into digital quantity. That is, the analog to digital conversion is completed for the CPU main system to judge the power system and whether the protected electrical equipment has faults or abnormal conditions. According to different analog to digital conversion methods, there are 2 common data acquisition systems: comparison transformation and voltage frequency conversion type. The conversion process of ADC data acquisition system needs to go through isolation, standardization or transformation of input, filtering, sampling, and analog to digital transformation. Therefore, the ADC data acquisition system consists of voltage forming loop, low-pass filter, sample and hold circuit, multiplex switch, and analog to digital converter. The main function of the voltage forming circuit is to connect the voltage from the voltage transformer, voltage and current of current transformer. It is proportionally transformed into a small voltage signal, suitable for the requirements of digital to analog conversion. At the same time, it can also play the role of isolation and shielding, and improve the anti-interference ability of the protection device. The figure shows the voltage forming circuit and the wiring principle of the primary system of the microcomputer line protection device. Line protection requires 8 analog inputs of voltage and current. The corresponding device needs to be equipped with 8 voltage forming circuits, 4 voltage converters, and 4 current converters. 4 voltage converters are respectively used for 3-phase voltages UA, UB, and UC on the bus side. Input conversion of line-side voltage UX for synchronous or no voltage detection with rec losing. 4 current converters are respectively used for input conversion of line 3-phase currents, IA, IB, IC, and 0 sequence, current 3I0. The function of sample and hold circuit is to measure the instantaneous value of continuously changing analog signal at a given time, and keep its output unchanged during analog to digital conversion. The so-called sampling is to measure the continuous analog signal at a given time, and discretize the continuous analog quantity through sampling for subsequent analog to digital conversion. After the discrete analog quantity is obtained by sampling, the conversion from analog quantity to digital quantity can be carried out. However, it takes some time from the start of analog to digital conversion to the end of conversion to output digital quantity. Obviously, during the conversion time, the analog quantity obtained by sampling should basically remain unchanged to ensure the conversion accuracy. That is, during the whole conversion process, the level of the sampled analog quantity shall be maintained. The device that can complete the above sampling and holding functions is called a sample holder. Sampling period and sampling frequency. The time interval between 2 adjacent sampling points is called the sampling period, which is recorded as TS, and the unit usually used is seconds or milliseconds. The sampling period and sampling frequency are reciprocal to each other. That is, TS equals 1/fs. For example, when the sampling frequency fs is 1200 Hz, the corresponding sampling period TS is 0.833 milliseconds. Sampling times per power frequency cycle is usually used to describe the sampling speed of the device. The number of samples per power frequency cycle is actually the multiple of the sampling frequency relative to the power frequency. For example, if the sampling frequency is 1200 Hz, the corresponding number of samples per power frequency cycle is 1200 divided by 50 is equal to 24. Take samples every 15 degrees. The higher the sampling frequency, the more times of wave sampling per week, and the more accurate the device will measure the analog signal. In order to ensure that the sampled discrete signal can truly represent the sampled original analog signal and enable the device to accurately measure the required analog signal, the sampling frequency must be greater than twice the highest frequency in the input signal, f greater than or equal to 2 fmax, which is the famous sampling theorem. If the sampling theorem is not satisfied, the frequency aliasing phenomenon of mixing high-frequency components with low-frequency components will appear. The function of switching value input and output system is to input external contacts into the protection device. And the protection device outputs tripping and closing commands and signals. In order to identify the operation mode of the protected object, the working mode of the device set by the user and the state of receiving other external devices, microcomputer protection device needs some switching value input, such as the reset button of the protection device, the function pressing plate, the rec losing mode switching switch contact, the time synchronization contact, and the contact of the tripping position relay receiving contact of receiver, etc. Microcomputer protection device also has many switching values output, such as tripping and closing contacts, transmitting contacts of transceiver, remote signaling contacts, central signal, and tripping signal contacts, etc. Some of the input and output quantities of the protection device belong to the contacts on the panel of the device itself. The introduction path of these contacts is very short and there is no circuit connection with the outside. They can be directly connected to the parallel interface of the CPU, as shown in the figure. Some switching values are led to the protection device from the outside through the terminal strip, and the introduction path is long or there is a circuit connection with the outside. Therefore, many interference signals may be introduced to the protection device, in order to prevent the operation of the microcomputer system from being affected by these interference signals. Photoelectric isolation shall be carried out between the microcomputer system and these external contacts through photoelectric coupler devices, so that there is no direct electrical and magnetic connection between the microcomputer system and the external contacts. As shown in the figure, some switching values, especially those connected by long cables, even need to take dual measures of relay isolation and photoelectric isolation before they can be led to the CPU of the protection device. For the power supply E in the figure, that is, the power supply used for the input circuit, it is often referred to as the input power supply. According to the voltage of the input power supply, the input mode can be divided into strong current input and weak current input. When the input quantity needs to be introduced from a distance, such as the auxiliary contact of the circuit breaker introduced from the breaker operating mechanism of the switchyard outside the protection room, the receiving contact introduced from the carrier machine in the communication room, etc., the input power voltage is 220 volts or 110 volts, which is called strong current input. For the input value located on the protection cabinet, such as functional pressing plate, rec losing mode switching switch contact, etc., the input power supply is usually directly from the optocoupler power supply output by the power plug-in of the protection device, and its voltage is only 24 volts. So it is called weak current input. Some types of protection devices also adopt or can choose strong current input mode for the input value on the protection cabinet. For example, WXH800 series microcomputer protection devices adopt strong current input mode. According to whether it returns automatically after action, the output can also be divided into two categories. One is that it returns automatically with the protection action, such as tripping and closing contact, remote signaling contact, etc. The other is to act and maintain with the protection. When the protection returns, it does not return automatically. It needs to manually press the reset button of the device or reset the remote signal before returning. Here, this kind of opening is referred to as magnetic holding opening, such as central signal contact, tripping signal contact, etc. The function of CPU main system is to collect the original data from the data acquisition system, and contact signal of switching value input system, analyze, process, calculate, and judge, to complete the relay protection function. CPU main system is mainly composed of CPU and various memories. At present, microcomputer relay protection devices often use single-chip microprocessor and digital signal processor at the same time. In the microcomputer relay protection device, the memory is used to store the sampling value, protection program and setting value of the device, as well as the intermediate data in the operation process. According to the needs of different tasks, microcomputer relay protection device adopts 3 types of memory: random access memory, read-only memory, and electrically erasable programmable read-only memory. When the protection device is running, CPU executes the program stored in EPROM in advance, stores the information obtained from the data acquisition system into RAM, carries out analysis and processing, and compares and judges the protection setting values in EPROM, so as to realize various relay protection functions. The man-machine interface loop of the microcomputer relay protection device is composed of keyboard and LCD. Through the man-machine interface loop, the operator can input, view, modify, and print the information or state of the relay protection device. In order to realize multi-computer communication or communication with background monitoring system, exchange information, microcomputer relay protection device. Usually, a communication interface loop is also set. It can provide RS-232/422/485 serial communication interface, field bus communication interface, Ethernet communication interface, etc. In order to improve the anti-interference ability, microcomputer protection devices usually use inverter power supply. This power supply can isolate the strong current DC system in the plant from the weak current system of microcomputer protection device. Its working process is to invert the DC into AC, and then rectify the AC into multiple groups of regulated DC power supplies required by the protection device, such as 5 volts, plus or minus 15 volts, and 24 volts.